What is the first point? You can see that the first point given is this one only. The first point is the number of circular permutations of n different things taken r at a time is NPR upon r. That is the first point. Circular permutation. What is NPR? Linear. Number of linear permutations divided by r will give you the circular permutation. And similarly, if you see the second one, by taking all at a time, it is n minus 1 factorial. Second one. Okay? That's an interesting thing now. Now, the problem in circular permutations is this. For persons or humans, the circular permutations will be different, but for the flowers in a garland, beads in a necklace, and for all these things, there will be a little difference. What makes the difference? If there are 4 persons, let me say A, B, C, D. Now, if you see, on this side, B is there, on that side, D is there. That is, in the clockwise direction, B is there to A. In the anti-clockwise direction, D is there to A. Okay, now, if it is written like this, in the anti-clockwise direction B here, in the clockwise direction D here. Okay, now if A is a human being, let me say I am A, then I will know left side to my left side some B is there, to my right side some D is there. If these two are interchanged, then I will be knowing B becomes D and D becomes B. Okay. So, when a human is there, human will be knowing left side and right side. Human will be knowing left side and right side. But if I am a flower, or I am a bead in a necklace, then the flower does not have any left side or right side. Do you understand what I am saying? A human will have left side and right side. That is why we will be knowing who is on the right side, who is on the left side. If they are interchanged, then we will be knowing left becomes right and right becomes left. But in case of flowers in a garland, that differs. That means very simple thing what you have to understand. Human being will have front and back, left and right, whereas the flower will not have all those things. So in this case, how do we define it mathematically? And if you take this as the anti-clockwise direction, and what is happening in this case, the same is becoming now in the, it is in which direction it is in the clockwise direction. In which direction it is in the anti-clockwise direction. These two will be different if it is the arrangement of human beings. These two will be different if these are the arrangement of human beings. But in this case, if flowers are placed, then let me say this is rose, this is lily, this is jasmine, let me say, and this is some sunflower. Whatever it is, 4 flowers are taken. Then what I'm doing, I'm interchanging this now. This is rose, this is lily, this is sunflower, this is jasmine. Then you may think, sir, this is different from this. No, it's not like that. I will reverse the garland. What makes the difference? Both will be same. Because that will not have any left side or right side or front side or back side. That means in the case of flowers in a garland or beads in a necklace, these two will be treated the same, but in n minus 1 factorial, they are treated different if they are the persons. So, when the clockwise and anti-clockwise directions are taken the same, these two will not be taken different, but they are to be taken one. But in this one, they are counted twice. That is why, in this case, what happens? Flowers in a garland or beads in a necklace, or mathematically we say that when clockwise and anti-clockwise directions are treated the same, it is not NPR by R, but it is 2r. Why divided by 2? Because these two counted twice if they are flowers in a garland or beads in a necklace. Similarly, this becomes n minus 1 factorial upon 2 factorial, or simply 2. So that's what is the third point. The number of circular permutations of n things taken r at a time in one direction. In one direction. In one direction means, in this case, both are treated as the same direction. One direction, or you can say when the clockwise and anti-clockwise directions are same, then it will be npr upon 2r. You can see that. And the fourth point, the number of circular permutations of n things taken all at a time in one direction, or you can say clockwise and anti-clockwise directions are treated the same, then it is n minus 1 factorial upon 2 factorial. Okay. Ninth problem. See, please see the slide there, please. Ninth problem. The number of ways in which 4 red roses, 4 white roses of different sizes can be made out to form a garland so that no 2 roses of the same color are to come together is. So these are the basic questions, of course, and you must understand that nowadays there are 2 levels to get into IITs, that is JEE Main and JEE Advanced. So for JEE Main, you must be thorough in the basic levels, and then JEE Advanced you have to go for the higher standard. That means from the basic level to the IIT level, if you want to be selected, then you must be strong in all the levels. So of course it can be taken as a basic level question. Now in this case, the number of red roses, how many red roses are there? The ninth question there, how many red roses? Red roses are 4. And how many white roses? White roses are also 4. Now the condition given here is no 2 roses of the same color should be together. That means red roses are like this. Let me say, they are to be formed as a garland. Don't forget that. Garland means it's a circular permutation. So these red roses should not be together. That means there should be at least 1 white rose in between these red roses. So how many places will be there among the red roses? Among the red roses, 1, 2, 3, 4. So in these 4 places, these white roses are to be arranged. Understand, while solving the problems on permutations and combinations, or after, in the probability also, divide the problem into operations. Divide the problem into different operations. That is, first operation, what we are doing. First of all, remember always, you have to fulfill the restriction given. What is the restriction here? 2 red roses should not be together and 2 white roses should not be together. So what is the first operation we are doing? First operation, that is a fundamental theorem on arithmetic. Fundamental theorem on arithmetic, or we can see it as principle of counting. To apply principle of counting, you must know the operations first. If you know the operations, you will not have any confusion first. So first operation, what I'm doing, I'm counting the number of places among the 4 red roses. How many number of places are there? 4 number of places are there. Among these 4 places, these 4 white roses can be arranged in how many different ways? 4 factorial different ways. Then you may think that, sir, how can you arrange 4 white roses in 4 factorial different ways? Because they are all will be same. All sizes will be same. Then how can we arrange 4 factorial? But you can see the question there of different sizes. Different sizes. Don't forget that. They are all of different sizes. That is why you can write it as 4 factorial. If they are like roses, then there will not be any arrangement. We have seen they will become like things, then that becomes 4 factorial upon 4 factorial. 4 factorial upon 4 factorial means only one will be there. Because they are of different sizes, it is nothing but 4 factorial. That means first operation performed of arranging the white roses among these are among the red roses. Then the second operation. What should be the second operation? All the 4 roses are to be arranged now circularly. Circularly means, how can you understand that circularly? Because it's a garland. Garland is always circular permutation. So it is 4 minus 1 factorial. It is nothing but 3 factorial. 4 factorial is nothing but 24. And 3 factorial, if I write, do you accept that? Do you accept that? No, because you should not accept. Because roses, these are roses. Roses, you must understand the clockwise and anti-clockwise directions are treated the same. Treated the same. Then in such a case, if these roses are humans, then it will be 3 factorial. But here the roses, you must divide with 2. Then it should be 3. First operation can be performed in 24 different ways and the second operation can be performed in 3 different ways. Therefore, total number of ways is equal to 24 into 3 is equal to 72. You can see the answer there. It is A, B, C, D. D is the right answer. It is 72. So understand that. So like this, if you solve the problems, always solve the problems of permutations and combinations by splitting into operations so that you will be more comfortable. Now, see the 7th question here, please. Just for the purpose of circular permutation, I am discussing this. See the 7th question. In how many ways can 11 men sit around a table so that all shall not have the same neighbors in any 2 arrangements? All shall not have the same neighbors in any 2 arrangements. This is a twist. Small twist is there in the question. This is a basic twist only, like it tests your fundamental or basic knowledge of the circular permutation. Now understand. How many persons are there? Totally 11 persons are there. If there is no restriction, because they are persons, humans, all those 11 can be arranged in how many different ways? All those 11 can be arranged in circularly in how many different ways? It is 11 minus 1 factorial, which is nothing but 10 factorial different ways. If there is no restriction, without restriction. Understand? Without restriction, they can be arranged in 10 factorial different ways. But there is restriction. There is restriction. So, it is in the question, so that all shall not have the same neighbors in any 2 arrangements. Shall not have the same neighbors in the any 2 arrangements. I'll answer that question. Cochin, I could see that. The rank of the word Cochin. Mr. Srinivas, I'll answer it soon. Please wait. So let us conclude this now. So, but here it is without any restriction, but in this question the restriction is there. What is the restriction? They should not have the same neighbors. Let me say, I am here and on my right hand side 1 person is there. On my left hand side, so let me say Mr. Srinivas is there on my right hand side. Ms. Aishwarya is there on my left hand side. Then we are arranged circularly. Then in those arrangements, which one we don't want? Which one we don't want? Mr. Srinivas on right side, Aishwarya on left side. Then there should not be any such arrangement wherein Srinivas comes to left side and Aishwarya goes to right side. What does it mean? In this case, understand, the right person, left person, and even though they are interchanged, are treated the same. What does it mean? The clockwise and anti-clockwise directions are treated the same in this case. That is a twist in the question. So understand, it should be like the flowers in a garland and beads in a necklace. So it is not 11 minus 1 factorial 10 factorial, but it is 11 minus 1 factorial upon 2 factorial. 11 minus 1 factorial upon 2 factorial, which is nothing but 10 factorial upon 2 factorial. Understand the question. Go to the question and understand the question and apply the concepts what you have learned here. There should not be same neighbors means they are treated the same. What are they? What are they? Clockwise and anti-clockwise directions are treated the